Hello and welcome to Breakpoint 2005. My name is Marcus. I work at Sony in London and I'm about to tell you about our new handheld, the PSP. Some of you might have seen it already, some not, and I'll just tell you what's inside and what you can do with it. Coming up, a quick overview, what's inside the sexy box and some gory details about its special chips. Ski, who's that? What is PSP? And what dev tools do we supply? And how can you become a PSP developer? Just as introduction, we at Sony are based here in London. Very nice. I do developer support, library development, and consulting. What is the PSP? For the video game consumer, it's a PlayStation product. You know, PlayStation is nice brand name and it's excellent. It's a multi-usage device. You can play games, videos, and music. It's very sexy. It's stylish. Quality screen, quality is 3D, and it's very powerful. For the programmer, you've got hardware which is dedicated for high power, fixed graphics pipeline, powerful. Okay. For the programmer, the hardware is fixed graphics pipeline. You've got a powerful VFPU. You've got a powerful audio system. And library-wise, we supply you graphics libraries, matrix libraries, FPU libraries, and vector libraries. The specs of the PSP are a dual-core MIPS 4K 32-bit CPU. It's got a dedicated 3D graphics engine. For video, it does H.264 ABC decoder in hardware. It's got a pretty cool 16:9 widescreen TFT LCD. It supports wireless, and for safe games, you get Memory Stick Pro Duo. The new device to it's the disk used is a UMD Universal Media Disk. It's a dual layer device which can store up to 1.8 gig for all your games and data. It's high speed transfer rate, it's in a protective case, shock proof, and provides a excellent copy protection, which I can hear some grins. It's very important though. Inside the PSP, you've got the game engine and the media engine. The game engine also contains the graphics processing unit, an R4K kernel, a FPU and a VFPU. The media engine, it's a separate R4K kernel, where you got the VME, the virtual media engine, the ABC decoder, and another R4K core. Everything is connected up to the I/O block, which then gives you the nice stuff on the LCD. The CPU itself is, like I said earlier, it's on MIPS R4K, which can be clocked runs between 1 and 333 megahertz. You can select it code-wise. Currently, it's locked at a lower rate to save some power. You have access to 33 megs of memory, of which some megabytes are reserved for the operating system. Still leaves you a big chunk to play around with. It's got 16K instruction cache, 16K data cache, 16K scratchpad, and it also contains an FPU 32-bit single precision. Vector operations are running on the VFPU at 2.6 gigaflops. Full instruction set provided. We also supply libraries and source code for it, and it's programmable like a normal coprocessor. Some of the graphics specs are quite impressive for this little device. It's a 512-bit bus at 166 megahertz. It contains its own 2 megs of RAM. The bus bandwidth is 4.3 gigabytes a second. The pixel fill rate of 664 megs a second, which actually, if I'm not mistaken, it's even higher than the PS2 was able to supply. And you can theoretically up to 35 million polygons a second, including T and L. It's pretty close to a PS2, but it's in much smaller size. It supports hardware lightning. Skinning is done on hardware. Morphing is also done in hardware. Tessellation is also hardware supported by this device. For movies, we use the AVC. It's an H.264 decoder. It's an MPEG-4 standard. And movies can be up to 4 hours on a UMD and in a very good quality. For audio, the audio is done using the virtual mobile engine, which is a reconfigurable processor which can be reconfigured on the fly. So what it does, it's used for the codecs. It saves you separate hardware pieces, separate dedicated chips. You just reprogram it once and it plays your whatever codec you need. For music, the user interface supports HTRAC 3 Plus and MP3. In games, you can only use HTRAC 3 Plus and ADPCM. For your save games, you have audio and video playback, and games have on your memory stick Pro Duo. Communications on a PSP is excellent. It got built-in wireless LAN, infrared, and USB 2. You can connect your PSP to a PS2, which then you can have talk from your PS2 to the PSP, or you can use the PSP as a mass storage device on your PC. Just connect it, turn it on, and you can save stuff. Libraries to support this are provided by us. Tools available for development. First of all, it's the PSP software emulator, which once you apply to become a developer, you will first have to prove yourself by developing some concept stuff using the emulator, which also comes with a debugger and a visualizing display. Next step is the hardware, which is a hardware tool, which is connected to a PC using normal Ethernet. It contains 64 megs of memory, 2 drive units. One of them is a real UMD drive, and the second one is a standard DVD-ROM, which is used during development time. It also provides battery emulation, so you can see how long your title will last, or if you're doing too much stuff like C-keying or loading too much. So it's a very nice tool to optimize your code. It also contains wireless LAN, so you can create your multiplayer games using multiple dev kits. It also contains a foot switch for the performance analyzer, an AV out and a VGA out, so you can connect it up to a VGA screen or a projector, which we might show you later tonight, so you can see it in real action. I know that some of you here are into the game industry or want to become it, and just telling you about a short way how to get a licensed PSP developer, or how it usually works. If you're already a PS1, PS2 developer, you just talk to your third-party account manager, and if you're new to PlayStation, you just visit our website www.newdevs.ski.net. Then the track is pretty easy. You just do the initial legal paperwork. Then you get free access to the tools, docs, emulator, and technical support from us. Then you have to submit your proof of game concept to third-party relations. After which, you get an order license to sign. After which, then you get the hardware tool. Your development continues. After you've created your game, next generation game, it will go through QA, and then it will release by an approved manufacturer if it passes. Why become a PSP developer? One of the most important things. We've got great conferences and parties, one of the main features. We've got a great developer support. It's very easy to program. If you know OpenGL, you can do a PSP more like out of the box. It's very easy. It's very powerful for its size, and our products lead the market. Yeah, you've got a question? Hmm? Well, our products, as Sony in general, like PS2, PS1 as well. Yeah. Now, quick overview what's inside the little box. We have a pretty big screen compared to some other devices which only provide smaller screens. So you have yeah. We also have 32-bit display compared to some 16-bit display. I don't know if you can see the difference. It looks much better in 24-bit. The graphics libraries build up from your 3D package. It goes through some libraries, lots of layers, until you hit the hardware. Or if you feel confident enough, you can go straight to it, to the graphics engine, directly, writing your own display lists. If you feel like it, there's nothing that prevents you to do the real stuff. Yes, please? Sorry? Yeah, you can build. You have two modes for doing the display lists. Either you send them like in one go, or you pre-calculate them and send them then. So you have direct, you draw, it displays the list, or you pre-calculate and then send it off in one go. You don't have to use the high-level libraries. You can go as slow as you want. You can write your own little display list. Yeah, you've got full access to almost everything, and the documentation is very nice and contains all the info you actually need. The graphics engine itself is a 166 megahertz chip with 0.664 gigapixels second. The display lists are made out of 32-bit comments. It's a fixed pipeline, specular, pixel blending, everything is more or less for free. It supports texture compression in hardware. It does hardware broadband and polygon clipping, and it supports bonding boxes also in hardware. The blending unit can do morphing in hardware with up to 8 vertices, and skinning is also in hardware supported with 8 bounds. I think it's the first handheld that supports built-in subdivision and PCI by hardware, and it also supports spline surfaces. As you can see, the same data as polygons look like this. In splines you have much nice and round. The TNL unit supports vertical vertex formats, like you're probably used to from doing OpenGL stuff. You can define it how you want your vertices. different formats, however you feel like it, how your engine. With different lighting modes, ambient, diffuse, specular, directional, spot, point, distance, attenuation. Texture metrics and shape mapping, everything is included in hardware, everything. So you don't have to calculate all this stuff yourself. The texture mapping unit supports 4, 8, 16 or 32-bit CLUD indices, the usual 16-bit color modes, and of course a 32-bit color mode as well. Points, linear and trivial filtering is supported, automatic MIP mapping up to 8 levels deep, texture compression, it got a texture cache which is 4 ways associative, and it can read textures from RAM or from VRAM. So if you think that 2 meg of VRAM are not enough, you can get all your data directly from normal main RAM. The pixel operation unit writes 0.664 gigapixels per second textured or non-textured. It writes 4 pixels at the same time. It's fully featured with free alpha blending, does fogging, dithering, color alpha stencil tests, and all logical operations for free and in hardware. So all you have to do is to tell it what to do, it does the magic. The performance, it got a fill rate of, like I said, 6.664 gigapixels. Seeing the screen is 480 by 272, that's 130,000 pixels. That gives you a fill rate of more than 5,000 screens per second, which is way more than a PS2 is able to do. What you can expect is better graphics quality, which can be used to make better games. The main CPU, it's called Allegrex, contains its instruction cache, data cache, and it's got another cache. It runs up to 333 megahertz. It can be set by the programmer to save energy and adjust the speed as needed. It's on 4K. It's got an extended instruction set, uncached write buffer, and it's got an FPU. One of the magic things about the PSP is the built-in vector floating point unit. It's 32 bits precision. It contains 8 matrices or 32 vectors or 128 floats. It's very flexible with its data reading. It supports prefixes, quick and precise approximations, and it got unseparated uncached write buffer. The library support vectors, matrices, quaternions, scalars, and random vectors. The frequencies for the CPU, VFPU, bus, and GE can be set separately, so you're very flexible and can adjust it to your needs. Now we go to some of the gory details, what the graphics engine, intrinsics, and Allegrex, VFPU, memory types, and some system optimization information. The graphics engine depends on the speed on a graphics engine depends on the size of the vertices and where they are. If you store your data in normal RAM, you get approximately this speed. The smaller the vertices, the more you can display. If you store them in VRAM, you can do much more. It's more or less like a free cache. The graphics engine does 4 pixels at the same time, which is not really sensitive for small polygons, so use it wisely. It got 8K texture cache as well. The textures can be in RAM or in VRAM, and a big amount of VRAM can be used as your own cache for your vertices, other data, whatever you want. The only thing you can't do from VRAM is running code. That'd be too good. And texture compression is in hardware. The only thing about the hardware texture compression to be careful about is every time you use a texture, it gets fetched and decompressed again, so use it wisely if you want to. Another nice feature is the intrinsics, so it uses all the new instruction set, the extended one. You can use it directly from C or C++, however you feel. It speeds up the code and it's very simple to program. Now I mentioned some extended instructions. You've got cache instructions, sync instructions. You get instructions like extract bit field. So if you want just access separate bits and bytes, you can move them around and extract them from one register and write them in the other one. And you can also insert bit fields. So you get one piece and can put it somewhere else in one instruction without having to fiddle around with the bits and bytes yourself. You also get functions to count leading ones and leading zeros. It looks like this. Data formats on the VFPU are 32-bit integers, 16-bit integers, 8-bit integers, 32-bit floats, 16-bit floats. The VFPU data access. As I mentioned, there are 128 registers which are organized logically as matrices. They are accessed as matrix number, column number, row number. Data types are scalars, column vectors, row vectors, matrices, or transpose matrices. So you don't have to care about playing around with your matrices. Everything does it. It's done in hardware. Scalars, you simply access them with an S at the beginning, matrix number, and then other number. Vectors are accessed like this. You mark them with a C for column vectors, or with an R for row vectors. You can have them with pairs, triples, or quads. Matrices, they are either normal ones or transposed ones, which are also accessed in a very similar way. You just prefix a register with an M or with an E. It took us quite a while to figure out why they came up with M or E, but then it looks like an M when they're like this, or an E like in this row, so at the end it's quite obvious. You can have 2x2 matrices, 3x3, or of course 4x4 matrices. You have target and source prefixes, which are applied before the FPU function, cosinus, sinus, and the other stuff. You apply it, it gets whistled, then the prefixes get applied, go through, and then the function is executed. For the destination prefix is applied after the VFPU function. There. Goes through, and it ends up in the destination vector. You can have saturation, masking with them. The VFPU can also use for fast calculations. It got everything built in for very fast math, so let's expect. There. You've got built-in arsin and cosinus and sin, which are extremely fast and to a very good precision. That's that one. Memory types on a PSP is you've got the normal main RAM, which is 32 megs. You've got 2 megs of VRAM, which is mainly used for graphics data. You've got cached and uncached access. You've got 16K scratchpad, which is not as fast as the one you're used to on PSP, but it's still faster than a normal RAM. You've got a data cache, 16K, and you've got a small write buffer. For system optimization, minimize your memory transfers, because everything you transfer goes through the bus, which slows down the CPU because you've got 2 cores and you have to transfer stuff in between, so keep transfers slow. Keep data in registers. Data transfers, best thing from core to core without having to
Trinity,
store the memory.
could you please talk a bit louder? It's really hard to understand back here.
Sorry.
Come on.
Yeah.
Thanks.
But unfortunately, I think I was too fast because I'm already very close to the end, actually. So to get you back from the delays. In assembly, also do the same. Use assembly and minimize transfers over the bus, so just the direct core transfers. As a conclusion, the PSP is almost as powerful as a PS2. It's very sexy, and there are great expectations for good games. Oops. End of slideshow. We will be able to show you some games in real action later tonight, I hope, on the big screen, so you can see how it really looks in action and what you can do with it. Unfortunately, I'm not allowed to tell too much because otherwise I would get sacked. Or if you have any more questions about the PSP and stuff.
I'm coming.
Thanks. I have a question. You showed that it's possible to have either you have 8 bones or the morphing targets.
Yeah.
Can you combine them, or is this a restriction? So can 4 or can I have 8 and 8?
You have 4 at the max, so you can have only 4 at a time.
If you said 8?
8, sorry.
Yeah, but the question is that excluding or including? Can I combine both technologies or not?
You mean morphing and?
Yeah, exactly.
Yeah. As far as I'm aware, you can.
I can. Okay. Thanks.
So you've mentioned earlier that Sony actually encourages people to downclock their games in certain occasions to save battery time. Is that actually a requirement for getting a title published?
No, it's not a requirement. There is no requirements of how long your game has to run or maximum distance. So whatever you feel like it. If you think my game is fine if it runs 5 hours, that's good. If you think my game is good enough, it runs 2 hours, that's fine. If at the end it's you want to have players playing it longer and keep them.
From a demo coder's point of view, what do you think makes the PSP interesting for demo coders? I mean, it's made for games, but do you think it have anything that's interesting for demo coders?
The thing is, you've got a handheld with all the dedicated hardware for 3D programming that you've got on the, say, first or second generation graphics card, and it does provide a lot of power. If you're here tonight, we might be able to show you, for example, games, Ridge Racer, to see what actually is possible. Or if you're around later, I've got a PSP with me, and a colleague who's with me also got a PSP, so you can have a look at it and see what it does. Programming wise, it's very simple. If you know OpenGL or something like that, it's almost the same. It's one. It's pretty simple.
Yeah, so it's interesting for the PC coders, but for say C64 coders or other more hardcore people, it's not a very interesting machine.
It actually is, because you can also go to the hardware. You can write your own display list. You can do your own effect. You can try tricks with having your data in VRAM and do some some stuff on it, getting it changed by the draw function, see what happens if, because you can access the VRAM directly from the CPU, so you don't have to copy stuff from the main RAM to the VRAM to be able to change it. You can write directly to VRAM if you want to, which of course slows stuff down, but you're free to do whatever you want with it.
If I want to write a program for the PSP without being an official Sony developer, just for the fun of it, is there any possibility?
Not at the moment.
Thanks.
You talked about the USB stuff.
Yeah.
Is it locked as a USB slave device, or can it also be put into master mode for it to have its own client devices?
It is in device mode.
So it's always like no possibility for like a USB keyboard that would be a slave device, like we have with the PS2.
Actually, there are keyboards in development for the PSP and devices, which run in host mode.
Okay.
Where the keyboard itself runs in
Right.
host mode.
Okay. All right. That's all I wanted to know.
Any other questions?
How do you expect people to get acquainted with the hardware if they can only lay their hands on the thing with being an official developer and having the developer kit?
Well, the thing is, I know that many people here actually are into game development business or want to get into the game development business. Saying that, if you guys want to become game developers, I know someone here, Chaos, is looking desperately for a PS2 programmer. So if you want to get into game development, talk to Chaos. He's actually looking for someone. Is the guy back there?
Just turn around and you see him winking.
Wave again. He's looking for a programmer. So if you want to get into development, he's the right man to talk to at the moment.
But it wasn't always that way. With the PlayStation, the original PlayStation, you had the Net Yerosi thing, so everybody could afford a developer kit and write their own stuff, and that's what it all started. Like the Dreamcast, free developer scene and everything. So why the change right now?
At the moment, it's too early to say if there are plans to open it up more for hobby programmers. I don't know what the future will bring, but we will see. On PS2 you had PS2 Linux, on PS1 you had the Yerosi, so maybe.
Is it technically possible to actually write your own games without having Sony to sacrifice all the encryption stuff and everything? So is there a path for free developers to access this thing without doing something illegal, like circumventing the DMCA or something?
Not at the moment.
Actually, the PSP was released only recently, so you might want to wait a year or two before see if there's any kit.
Yeah.
When PS1 came out, it took a year or two for the Net Yerosi kit to come out. The same thing was for PS2, so PSP just came out a few months ago, so I would rather wait first before I complain if it's possible or not.
Yeah, that was my colleague. He's also at Sony. And yeah, we are actually 3 people of us are here. Everyone is carrying a PSP with him. So if you catch one of us, you can talk to them, ask them to show you the cool stuff. But just don't try to mug them and steal their PSPs. That'd be not very nice. Are there any technical questions? No? Well, then that be it for me for now.
I'll just have a go at a technical question. Can this thing boot over the network, just like the Nintendo consoles do?
What
So
do you mean boot
you-
over the network?
You put a game in one console and you can start a multiplayer game with just one person having a disc or a card or
Yes.
whatever.
Yes, you can. It got built in wireless, and using the wireless you can have a feature. It's called game sharing. So you can transfer part of a game to another PSP, which does not need to have the UMD in.
Okay, I actually have two questions. One, with the wireless, the 802.11b, does
Yeah.
it work both in infrastructure and ad hoc mode?
Yes, it does.
Okay, and what about the power drain while it's in the wireless mode?
Activating the wireless chipset increases the powertrain and reduces your battery life.
Okay.
That's why the battery emulator comes in handy, so you can see exactly what happens.
Right. And the second one is, in regards to the DMA, with the PlayStation 2, we had a dedicated, what we called the DMAC, which was our dedicated DMA chip, which we used to route things between the IOP or the GS. Or do you have a similar type thing on the PSP, or does it go directly from the CPU to the graphics chip?
Everything the DMA related is handled by the kernel itself.
So we can't, we're not going to be handling the DMA directly
No.
anymore?
No.
Can we anymore, or do we have to use through the kernel itself?
Everything is handled internally. I've never actually anyone seen doing DMA by hand.
Okay, just curious because I work with the PS2, so trying to see what's going on.
If you are used to PS2, you will see how much easier PSP is. It's like, whoa.
Yeah, but that's kind of the appeal of the PS2 is the low level, kind of like working with Amiga or anything else, is the really low hardware level stuff, the more challenge in developing for the console.
Yeah, I see what you mean, but there are so many people complaining about the PS2 being such a raw hardware. Go do stuff.
Yeah.
Create yourself. Now on the PSP we supply all the nice stuff, which makes it easy for you, but you can go very low on the hardware.
Right. Okay.
No one else?
Okay. Fantastic.
So that's it? Okay.